Okay, welcome back. This is Mr. Hassan's Maths channel, and this is now question number 2 from the Statistics S1 June 2014 International A-Level Edexcel exam. And this question here is about this grouped frequency table, which shows the distances to the nearest kilometer traveled to work by the 50 employees in an office. So they give you the distance, the frequency, and also the midpoint of the distances. And they've also given us some summary data. They have given us the sum of the frequencies times the distances, the product of the frequency times the distances, the product of frequency and distances, and the sum of all of those, and also the frequency times the square of the distances, the sum of all of those. They've given us that. And it says a histogram has been drawn to represent these data. The bar representing the distance of 3 to 5 has a width of 1.5 centimeters and a height of 6 centimeters. Calculate the width and height of the bar representing the distance of 6 to 10. Okay, so now what we need to do here is we need to think about what is it that's going to affect the width and what is it that's going to affect the height of the bar. Okay, so if we think about the width of the bar first. Okay, so I'm going to, as we're finding the height of the 6 to 10 bar, I'll write the 6 to 10 bar first, and then I'll write the 3 to 5 bar. Now, what's going to affect the width of the bar in a histogram? It's physically 1.5 centimeters width. What affects it is the interval. Okay, how wide the interval is for the group. That's what affects the width of the bar. Now, the interval here, because we got data where there's gaps in it, where the numbers were rounded to the nearest kilometer, these numbers don't actually represent the width of the bar. The width here is not, for example, 2. And the width here is not 4. In fact, the widths of the bar include the numbers that were rounded up to 3 and rounded down to 5. When you, for example, the number 2.8 would have gone in this group. The number 5.2 would have gone in this group. Okay, so what we have to do is think about the lowest this could have been, which would have been 2.5, and the highest it could have been, which would have been just before 5.5. So that's actually the beginning and end of the group. Okay, you would have written that as, that would have been written as like 2.5 is less than or equal to the distance, and 5.5. That's what the actual group is. 5.5 itself is not included, but everything just before it is. Okay, so the width of the group is actually 3, not 2. Okay, so that's very important. The width of the interval is 3 units. Okay, so if we think about the interval width, okay, I'll just write it as the interval. The interval for this group is going to be not 2 but 3. And similarly, this goes from 5.5 to 10.5. So the interval of this group is actually 5 and not 4, as you might think. Okay, that's one thing we've got to realize. So if we look at the 6 to 10 group, which we have to find the width of, I'll call it W, the width of this is going to be having to represent a width of 5 units, and we know that the width that they gave us for 3 to 5, which is 1.5 centimeters, is representing a interval of 3 units. The 3 to 5 bar has an interval of 3 units. Okay, so we want to find how many centimeters represents that 5 units. So we can use a simple proportion. We can say the width is going to be 5 multiplied by 1.5 divided by 3, just by proportion. So that gives us an answer which is 5 times 1.5, which is going to be divided by 3, which gives us 5 over 2, which is 2.5 units. So the width is 2.5 centimeters. That's the width of our bar. And now look at the height. What is it that determines the height of a histogram? Well, what determines the height of a histogram is its frequency density. The y-axis is the frequency density in a histogram. So what we got to do is work out the frequency density of each of these 2 bars, and then we can work out what height will represent the bar we're looking for. So the frequency density of this bar is the frequency divided by the interval. So it's 12 divided by 3, which is 4, and here it's 10 divided by 5, which is 2. So for the 6 to 10 bar, which we have to find, the height of the bar is representing, or is going to have to represent, a frequency density of 2. And for what we're told, that the 3 to 5 bar, okay, it's we know that it's 6 centimeters, which represents a height of a frequency density of 4 units. For the 3 to 5 bar, the frequency density is 4 units. So we want to find how many centimeters represents 2 units of frequency density, if 6 centimeters represents 4 units of frequency density. So we can just cross multiply here. We can have 2 times 6 over 4. So the height of the bar is going to be 12 over 4, which is 3 centimeters. So that's the width and the height of our histogram. So we can say that the 6 to 10 bar has width on the histogram, width of 2.5 centimeters and a height of 3 centimeters. And there's the answer to part A of the question. Very typical type of question about histograms. Okay, one little point I would like to mention here is that although we didn't use the midpoint in this question, that the midpoint of 0 to 2, why is it 1.25? Okay, as we mentioned, this is going to be 2.5 to 5.5, so halfway between them is 4, because if you add them together and divide by 2, you're going to get 8 over 2, which is 4. But here you can't go back half. The distance, you can't say minus 0.5. So this is from 0 to 2.5. So this is actually from 0 to 2.5. And if you find that halfway between 0 and 2.5, it's like 2.5 divided by 2, which is 1.25. Just a little point. We didn't actually have to use that at all in this question, but just to explain why that's 1.25 in case you were wondering. Now part B, it says use linear interpolation to estimate the median distance traveled to work. Okay, so we're going to estimate the median. Of course, we cannot find the actual value of the median because we don't know the actual values of any of the data. We just know how many pieces of data lie in each of these groups. So now, the median distance, which is called, the median is called Q2, we've got to first find its position. Okay, first find where it is. Which group does it lie in? Now, the position of the median, if we got grouped data, which we have here, and we know that there are, as it says in the question, 50 employees in the office, so we don't have to actually add the frequencies together. We know that there's 50 employees in the office, so I know that some of the frequencies is 50. The position of the median, if you have group data, the way I like to work it out is by using n over 2, which is going to give you 50 over 2, which is 25. So it's the 25th term. Now, if it was data that was not grouped, if it was like data that we had the actual values of everything, then I would say 50 over 2 gives you 25, but there's an even number of entries, so there's two middle entries, so I'll take the 25th and the 26th entry. Okay, but in this case, I'm going to just take 25 because it's group data, we don't know the exact values of the data, and there's, this is one of the methods we could use. Now we could use the method of taking the number 25.5 if you use n plus 1 over 2, and that's in the mark scheme as well. Okay, the mark scheme has sometimes a number of different methods which all are acceptable in statistics, and which, as long as you use a method which is correct, is fine. Now this is the method that I teach and I stick with because I find it more consistent and less confusing for my students. So I just use, when it's group data, 25, the number divided by 2, I take that answer, whatever it is, whether it's a whole number or a decimal, and I use that as the position that I'm looking for. So first of all, we've got to work out where is the 25th entry. Now if we see the frequencies, there's 16 entries in the first group, and the next 12 entries are in the second group. By the time you've got to the end of the second group, you're now on the 28th entry. So our entry that we're looking for is going to be in this group here. Now remember, this group actually, it says 3 to 5, as we discussed earlier. The actual width of the group is from 2.5 to 5.5, as we mentioned before. Okay, so you can say Q2 is in the 3 to 5 group. Okay, so what I'm going to do is now I'm going to make like a little kind of, you can say, a sketch of this group. This is how I like to do linear interpolation. There's different methods people use. Again, I like to use this method. So I know that I'm in the group from 3 to 5, which actually means it starts from 2.5 and it ends at 5.5 in reality. Now, by the beginning of the group, you're on the 16th term. By the end of the group, you're on the 28th term. Okay, that means, as we can see, the group is 12 entries wide. There's 12 entries in that group. We're looking for the 25th entry, which is Q2. So to find Q2, I like to use some sort of a proportion. Okay, I ask myself, how deep into the group are we? Okay, divided by the width of the group. Well, from 16 to 25 is 9 units. So the fraction that we are into the group is 9 over 12, like 3/4 into the group. So we can say Q2 is going to be that fraction into this group in terms of its value, in terms of the distance here, the value of the category. So we're going to be somewhere above 2.5. How much above 2.5? Well, 9/12 of the width of the group, which is from 2.5 to 5.5, which is 3. That's what fraction of this interval that we're going to be into the group. And that will give us Q2. Okay, that will give us Q2. So you have 2.5 plus 9 over 12 times 3, and that gives us 4.75. So Q2 is 4.75. That's the answer. That's the median value. That's an estimate of the median using linear interpolation, which is what we did. As I said, some people would take 51 over 2, n plus 1 over 2, give 25.5, and the answer would be slightly different, but it really has no problem. Both of those are acceptable in the mark scheme. As long as you stick to one of the acceptable methods, you're fine. Okay, this is a method that I prefer to use, so that's what I'm showing on my video. Now, part C says, show that an estimate of the mean distance traveled to work is 7.88 kilometers. And then it says, estimate the standard deviation of the distances traveled to work. Okay, so now, first of all, they've helped us a lot in this question, because to find the mean, what we normally have to do is do f times x and find it for each of these values, and then find the sum of those, and that's already given to us. And to find the standard deviation, which is part 2, we'd have to have f times x squared, find the sum of all of those and add them together, which they've already given us in, the summary data here. So this question becomes really simple because the information is given to us. So the mean is basically the sum of all the entries divided by the number of the entries. We don't have the entry values, the exact values, so that's why we use the midpoints, because it's like an estimate. There's 16 entries somewhere between 0 and 2. We don't know what they are, so we use the midpoint of that interval. There's 12 entries between 3 and 5. We don't know what they are, so we use a midpoint of that interval, and so on. And remember, the midpoint of the interval is halfway between these numbers. Now here, okay, why is the midpoint here not 1? Why is it 1.25? Because, as I mentioned before, each of these are actually gone a half this way and a half that way. Now, if you go half, this is actually 2.5 to 5.5. Right, so halfway between them is the same as a halfway between 3 and 5, because you've gone both ways a half. Now here, this is from 2.5, but this can't go less than 0, for it's a distance, can't go less than 0. So halfway between 0 and 2.5 is 1.25. That's why that is not like the sum of those divided by 2. You've got to take that into account when you are working the midpoints. Now, so as I said, all of that information is given to us here anyway. So if you want to find the mean, all I have to do, so let's do part 1 here. I have to take the sum of the f times x, which is 394, and divide it by the number of entries, which is 50. And that will give us the mean. So we take 394 divided by 50, and that gives us 197 over 25. 197 over 25, which is equal to, just press SD, 7.88, exactly as they told us to show. 7.88 kilometers. So that's the mean. That's part 1 done. Now for part 2, the standard deviation. Well, again, they gave us everything we need. Now the standard deviation, one of the nice phrases you can learn to help you memorize the formula, is the mean of the squares minus the square of the mean. Okay, I'm going to also explain to you the actual origin of the standard deviation, but first we'll just answer the question. So the mean of the squares minus the square of the mean. Now the mean of the squares means that you add together the square of each of the entries and then divide by the number of entries. So here the mean of the squares would be like 16 times 1.25 squared, plus 12 times 4 squared, plus 10 times 8 squared, and so on. Add all those together and divide by 50. Well, they've already given us f times x squared and the sum of them all. So that's the mean of the squares part, which is 6,500, divided by the number of entries, minus the square of the mean, which is the square of this number, what we found earlier. I could use 7.88 squared because it's not a rounded value, but this in general is what you do. You take away the square of the mean and use the mean in its more exact form. If that had been rounded, then it would have been more sensible to use the fraction, which is before you round it. So I've just put that there anyway, although this actually gives you an exact value, so you could actually use that with no problem. But this would give us the variance. Now the standard deviation is the square root of the variance, so it's the square root of all of this, and it gives us a measure of how spread the data is away from the mean. Okay, so now if I take this and I find the square root of 6,500 over 50 minus the square of the mean, so minus 197 over 25. Close that bracket, whoops. Close that bracket and then square that. That's the mean of the squares minus the square of the mean, square rooted, and that gives us 8.2404. 8.2404 continues, so we can say the standard deviation is equal to 8.24 kilometers. That's to 3 significant figures. Okay, so there's the standard deviation. Okay, and there's the mean. So that's part C answered. Okay, now before I go to part D, okay, I just want to explain something here. The standard deviation, what does it actually mean? It actually means how far each data entry is spread from the mean. It's like an average, and the average spread of each data entry from the mean. So the actual origin of the standard deviation would be the x value of each term minus the mean squared, the square of the distances of the difference between each distance. So it would be the sum of all of the differences between each data entry from the mean. Okay, you take that difference, you square it, you add them together, and you'll divide that by the number of entries. That's the variance, and then you find the square root of that. That's actually what the standard deviation is. Okay, but this is just a convenient formula that is derived from this, manipulated to give us this formula here. But that's actually what it is. It's like the average, it's like the average spread or distance from the mean of every data entry. Now that's going to help us when we're answering part E to understand that's what the standard deviation is. So we'll come back to that in a little while. Now part D says describe, giving a reason, the skewness of these data. Now the information we have about this is about this data is the mean and the median. Okay, so if we compare the mean and the median, now if you were to draw like a distribution of this, if you find that the data is symmetrical like this, if it was like symmetrical, okay, the histogram would be something symmetrical, then the mean, the mode, and the median would all be kind of like the same, roughly the same. But if you have data which is like this, where more of the data entries are concentrated on the lower end, okay, on the lower end, this is called positive skew. And when you have more of the data entry concentrated on the higher end, okay, of the scale, more on the higher end, this is called negative skew. Positive skew gives you this kind of like snail shape with the tail pointing towards the positive side. Negative skew gives you this type of shape with the tail end pointing towards the negative side. So this is positive skew, this is negative skew. Now, the median will always be like a bar which is higher up than the mean if it's not skewed, if it is skewed. So this would be a median here, and this would be the mean. In this case, that would be the median, and the mean would be somewhere less than it. So we can see that when the median is less than the mean, then we have positive skew. When the median is greater than the mean, then we have negative skew. So we can see here that in our case, we can say that the median is definitely less than the mean. Okay, the median is less than the mean. The median is 4.75 and the mean is 7.88. So it's going to be this type of situation here where we have, therefore we can say positive skew. So we have to give the skewness and the reason for it. So this is the reason and this is the answer. We have positive skew. That's part D. Now we're going to move on to part E. It says Peng starts to work in the office as the 51st employee. She travels a distance of 7.88 kilometers to work. Without carrying out any further calculations, state, giving a reason, what effect Peng's addition to the workforce would have on your estimates of the mean, the median, and the standard deviation. Okay, let's start with the mean. Okay, I've got this here just to show you something later. I'll just put it out of the way for now. Okay, let's start with the mean. We don't actually have to do any calculations for this, but I want you to understand. Now, first of all, Peng's distance is the same as the mean, 7.88. Okay, so for let's do part E part 1. So we can say Peng's distance is equal to the mean. Okay, it's the same as the mean. Therefore, there will be no change. No change in the mean. Okay, because her distance is equal to the mean. And I'll just illustrate to you an example. Supposing I have numbers 1 and 2 and 3. Okay, you don't have to show this at all. This is enough for your answer, but I want to explain to you why. All right, supposing we take the mean of these numbers, we have 1 plus 2 plus 3. That's going to give you 6. All right, so the mean is going to be 6 over 3, which is 2. So the mean is equal to 2. Supposing I add another number, which is the same as the mean. So I add another number, and I call that, say it's the number 2. Supposing I add the number 2 to the data. Okay, so add the number 2 to the data. So the new mean is going to be 1 plus 2 plus 3 plus 2, which is 8 over 4 this time, because it's now 4 numbers, which is going to give me also 2. So the mean didn't change when I add a number which is the same as the mean. Okay, when I add a number that's the same as the mean doesn't change. So I hope that makes that clear. Now, let's go on to the median. Okay, I'm going to again show you another example about the median. I'll use the same logic behind it, and just to make you understand. Now, we can see that Peng's distance, which is 7.88, okay, is more than the median, is greater than the median. Okay, so what happens when we put a number in that's greater than the median? Let me explain to you from another example like this. Supposing I put, we'd work out the median. Of course, the median here is very obviously 2, the one in the middle. So if I add another number which is more than the median, so let's say we add the number 4, we'll end up with 1, 2, 3, and 4. So the median now becomes 2.5. You can see the median has increased. I added a number that's greater than the median, therefore the number has increased. Same thing's going to happen with this situation here. And we can maybe illustrate it with this. Okay, so that's like the basic understanding. If I added a number, let's say if I added a number that's less than the median, for example, if I added a number 1, I'll have 1, 1, 2, and 3. And you can see if I add a number less than the median value, what's going to happen is the median is going to now become 1.2, 1.5. So the median will have decreased. So if you add a number more than the median will increase. If you add a number less than the median will decrease. Okay, so that's how you can think about that. Now, so if we think about it in terms of the frequency table, as I said, we don't have to. So her distance is more than the median, therefore the median is going to increase. Median increases. We just write that as an answer. We don't have to explain more than that. That's fine. That's enough for the explanation. But I'm just showing you here how that works, just for your understanding. That's all. You don't have to write any of this explanation. That's enough for your answer. I'm just explaining to you how it works in case you don't understand why would the median increase if you put a value bigger than the median value. It increases because it pushes the median further this way. Okay, because you're adding numbers to the right. Okay, so you know, basically it pushes the median that was like there before further back, so the higher number will become the median. But if you put a number before the median value, then it pushes the numbers further to the right, therefore the median gets less. Okay, now let's look at it in terms of the frequency table. So her distance was 7.88. Now 7.88 will be over here. So now instead of 50 entries, there's 51 entries now. And her entry goes in here, so there's now 11 entries over there. Okay, 7.8 would be somewhere in there. So there'll be one more entry in this group here. So let's see what that happens. What happens to that? Oh, the original median was 2.5 plus, and remember it was like 28. It was 50. It's 25, and 25 minus 16 was 9, so it was plus 9 over 12 times 3. Okay, that was the original median. Now the new median would now be, it would still be the same group, because 51 divided by 2 gives us 25.5, so it will be 2.5 plus, but now it's going to be 25.5 instead of 25, so you're going to go from 16 to 25.5, so this will make this become 9.5 over 12 times 3. So now we have a bigger portion of the 3 that we have to add to 2.5, so you can see it's going to increase. Okay, I mean, you don't have to show this with steps at all. I'm just showing you how it would work, because now our median, the median value is not going to be 9, is not going to be 25, it's going to be 25.5. So 25.5 is, before 25 was 9 along the group, 25.5 is going to be 9.5 along that group. Everything else remains the same. So this is a bigger fraction of the 3. So it'll be 2.5 plus a bigger number. Therefore, the median increases. Okay, so that's just to illustrate that. Okay, it's not something you have to show at all. Okay, if you understand, as I showed you from this, the basic understanding, if you put a number in that's bigger than the median, it will cause the median to increase. If you put a number in that's smaller than the median, it will cause the median to decrease. Here it becomes 2.5 when it was 2. Here it becomes 1.5 when it was 2 before. Okay, so that's just a little explanation which you don't have to show. This is fine for showing your answer. And number 3, or part 3, says what happens to the standard deviation. Okay, now the standard deviation is, as I mentioned before, its origin is the sum of each entry minus the mean squared over the number of entries. Now, so basically you're taking you'd say the midpoint minus the mean, okay, and squaring it. So this would be 1.25 minus 7. So if you're thinking about it, 1.25 minus 7.88 squared divided by, or plus, sorry, 4 minus 7.88 plus 8 squared plus 8 minus 7.88 all squared plus 15.5 minus 7.88 all squared, and so on. That's how you'd find the mean. Okay, now for her value, which is 7.88, okay, 7.88, her value is exactly the same as the mean. So if you did this for her value, if you took away the mean from her value, it would give you 0. So for the sum of all the entries, you're going to be adding a 0, because it's going to be 0 squared, and you're going to be dividing by one more entry. So the numerator of the fraction will remain the same, because you're adding 0 squared to it, but the denominator of the fraction is now going to be one more. So if you're dividing by a bigger denominator, you're decreasing the value of the fraction. So we can say that the standard deviation, therefore, is going to decrease. So we can say the standard deviation will decrease. Okay, the reason being why? Because the mean, or because her distance is equal to the mean. So let me do the same way I did it. Yeah, we say Peng's distance is equal to the mean. Therefore, the standard deviation is going to decrease. Okay, and I hope you understand why. All right, because the square of the difference between her value and the mean is going to be 0, and you have to add that to the numerator. So you're adding 0 to the original standard deviation numerator, but you're dividing by one more entry. Okay, so the square root of that is the standard deviation, so therefore the standard deviation is going to definitely decrease, because you're going to have a smaller fraction. The fraction will have a less value because you're increasing the denominator and leaving the numerator the same. Okay, like 1 over 2 and 1 over 3. 1 over 3 is less than 1 over 2. increase the denominator and leave the numerator the same, it's going to be less. So I hope that was clear. The standard deviation will decrease. So this is the mean is going to have no change. The median is going to increase, and the standard deviation is going to decrease. Okay, so there's the answer to question number 2, part E, and that completes this question. Other questions from this paper, when I get around to answering it, will be in this playlist that should appear somewhere in this area. Other questions from this topic of basically, you can say measures of location and spread will be found in this, and also I guess histograms as well can be found in this, in the playlist that should appear in the link over here, and you can see other questions about S1 histograms and in general in this playlist, and you can subscribe to my channel by clicking on this link over there. Thank you for watching, and see you soon.